Good afternoon, everybody. Hope everybody's safe. Welcome to the third in our weekly webinar series, a new approach to progressive cavity pumping and design. I'm Jerry Connolly. I'm with Siewert Equipment Company. Please tune in next Tuesday for our fourth webinar. That will be on screen selection and hydraulics, and we'll have a representative from Vulcan doing that seminar. Joining me and conducting the seminar today is Chris Davis. Chris is the Northeast Regional Manager. Chris is with Seepex. I do have a couple of housekeeping issues before we begin, please. There will be questions at the end, but please feel free in the question box on your control panel to the right side of your screen. Please feel free to type in your own questions. I will monitor those questions, and then once we're done with the seminar, I'll feed those questions individually to Chris, and we'll answer as many as we can as time permits. The timing is Chris is going to try to get done right around 12:45, 12:50, so we have 10 to 15 minutes for questions. Any questions that we do not get to, we record, and then we will respond in a group email with questions and answers. To receive PE credit, you must complete the survey evaluation that's going to appear at the end of Chris's seminar. So please stay connected while you complete the survey. And then at that time, or really any time, you can also download a certificate of completion. Please enjoy the seminar. I'll turn it over to Chris Davis. Chris?
Thank you, Jerry. Thank you for everyone in attendance. Today we'll be discussing progressive cavity pump design and upgrades to older technology for the modern market. Those of you that are not familiar with Seepex, Seepex is a United States manufacturer of progressive cavity pumps and macerators. There is also a German branch. Our factory in Ohio produces all of the stators for Seepex internationally. I've been with Seepex for a little over 4 years and run a territory from Canada down to Virginia, and I will leave my contact info on the last slide of this presentation. Some of the environmental applications that we will discuss today for progressive cavity pump. Number one will be sludge from 1 to 8% solids. 2 is thickened sludge and cake up to 50% solids. We will talk about some chemical metering applications, polymer, sodium hypochlorite, and lastly, dewatering and transfer. Now, if we look at the pump market as a whole, there's 2 distinct types of pumps. You have dynamic or centrifugal pumps, which import velocity to the fluid. Most of these pumps are located under a level being pumped. And then you have positive displacement pumps. Now, these pumps, it's due to the rotation of the elements that the liquid is moved out of the pump. And we can divide that into 2 main categories. We have reciprocating pumps, which are like diaphragm and piston or plunger style pumps. And then you have rotary pumps. Within the rotary category, there's multiple rotor pumps, as in a gear or a rotary lobe pump. And then you have a single rotor pump, which is a progressive cavity pump, also called an eccentric screw pump, or some people call it the worm pump. So key characteristics of a progressive cavity pump, okay, if we look right here under performance, okay, there's 2 lines. One is dotted, which represents a centrifugal pump, and one is a solid line, which represents a progressive cavity pump. So as the pressure increases in a certain system, centrifugal pumps, the flow will drop off. With a progressive cavity pump, there is very little flow affected by changes in pressure. We move on to flow rate. As the viscosity of a certain product increases, okay, the flow rate will drop off with a centrifugal pump. So when you're handling something that has some viscosity to it, you might want to switch to a progressive cavity pump because our efficiency and our flow rate will actually increase. We actually like to pump something with more viscosity than something as liquid like water, for instance. Efficiency. So when we look at sizing these pumps, okay, with a centrifugal pump, they're looking for this area right here called BEP, best efficiency point. With progressive cavity pumps, it's a pure linear curve. There is no best efficiency point. Applications to use a progressive cavity pump in: shear sensitive products, adhesives, high metering requirements. This would be something like maybe a polymer. When we look at the food and beverage industry, a shear sensitive product might be something like yogurt, or the cosmetics industry might be something like a conditioner. Anything that requires low pulsation requirements, low NPSH value requirements. And then when we move on to here, when we talk about sludges in the environmental market, stable or varying pressure and low to high changing viscosities. You would take a progressive cavity pump and most likely put it in application where you'd have maybe a 2% up to a 6% solids sludge, for instance. When we look at the actual cutaway of these pumps, they are designed to handle solids. These are used in a lot of different applications besides the environmental market, and we can get into that a little bit later. You'll see these pumps in the food and beverage market, sometimes in breweries for handling something as thick as spent grain. You'll see it in the yogurt and the dairy industry. You'll see them in pulp and paper production. And in the environmental market, as we discussed before, you'll see them in a lot of sludge and cake and chemical metering applications. Features of progressive cavity pumps. The capacity or the flow is directly proportional to speed. If you increase the speed on these pumps, the flow will increase as well. Pressure changes. The capacity is relatively unaffected by pressure changes. So if there is a 10 psi spike for some reason in an application, the flow is very little affected. Changing viscosities. If your sludge increased from 2% to 8%, you will see a very little change in flow as well. The other interesting thing is that these pumps can be reversed. You can actually pull flow into this pump. You can pull a sludge into a pump rather than pump it or push it. And I can show you a nice video clip of that coming up. When we actually look at the breakdown of this pump as well, I'll start at the back. What you're looking at here is the drive end. This is usually a close coupled gear motor. Then we move on to the seal element. It's usually a single mechanical seal, although some customers still use packing. Right here we have the suction housing and a universal joint that connects your drive end with your rotating end. And then over here you have the stator, which is usually a type of elastomer, which is compressed 20 thousandths of an inch onto a rotor, which is typically made out of a different type of metal. When we look at a progressive cavity pump curve, as you can see, it's purely linear, and it is mainly based on whatever the max pressure is in the system per RPM will give you your flow. So as long as you know the RPM of the pump, you have an idea of the pressure in the system, you can follow this over and find your flow. So very easy pumps to calibrate. With that being said, you know that your pump is getting tired, okay, and you can proactively do maintenance on it. Because if you can see that, let's say at 300 RPM, you always had 15 gallons a minute. Well, one day you come out and you check and at 300 RPM, you're only getting 10 gallons a minute. Okay, well then you know that probably your pump is starting to wear a little bit and it's now time to do some proactive maintenance on it. Why is it called a progressive cavity pump? Well, as the rotor turns, and if you're staring at the pump, it looks like the rotor's going up and down. But actually, as it's turning, it is opening and closing these cavities right here, which are filled with liquid. So because of this compression fit, if the pump is not turning, it actually works like a valve and everything is held not only in the pump, but on the suction and the discharge line as well. So this pump actually does not require a check valve unless the customer prefers one. Here's a nice demonstration of a progressive cavity pump. This is pumping a slurry of sorts with little bits of solids in it. As you can see, this is the suction housing. The pump rotates fairly slow. Progressive cavity pumps are sized to run at about 350 RPM down to about 50 RPM. That's the sweet spot. As you can see, as the rotor or the worm is turning, it's opening and closing these cavities here and gently moving the fluid through the pump. None of the particles are being damaged, and as you can see, it's not a pulsing pump. The flow is coming out rather laminar. If you reverse the rotation of this pump like so, you can see that it can actually pull into the pump rather than pump. Just by changing the rotation of this pump from clockwise to counterclockwise, you can change the direction of the fluid and how it enters or discharges the pump. So let's talk about one of the main pumping elements, which is the rotor. It is a single external helix, okay, and it is eccentrically manufactured. These can be made out of different types of metal, including stainless steel, tool steel, or for the manufacturer that I work for, we actually impregnate hard chrome onto it. Then you have the stator, the second pumping element here. This stator can be made out of various types of elastomer, Buna, EPDM, Viton, and many more. This is the stationary pumping element. This does not rotate, and it is tightly compressed onto the rotor at 20 thousandths of an inch. It does not matter which direction the stator is put on because the helices are 180 degrees opposed. Now, you look at some progressive cavity pumps out in the market, and some are larger than others in length. Now, why is that? Well, there's two reasons. One would be a certain flow rate that's required, and two would be the stages of pressure. These pumps, when we size them, are sized in various stages based on what the max pressure is that that pump can overcome. So a smaller pump would be a single stage pump, and that pressure can go up to about 90 PSI or 6 bar. As we increase the size of our pump, we can overcome higher pressures. So as you can see, the longer the rotor, the higher the pressure. This long rotor is considered a 4-stage pump. It is 4 times the size of a single stage pump. It can go to 24 bar. And the middle range here, another common pump that's sized up as a 2-stage pump, which can go up to 180 PSI. Operating conditions for progressive cavity pumps. These pumps can be sized to go from drops per minute for little tiny itty bitty progressive cavity pumps used for chemical metering up to about 2,000 gallons a minute. These pumps are relatively larger than a truck. You can go up to pressures of 720 PSI. The temperature range is roughly -4 degrees up to 350. That's based on the elastomer and metal choices available for these pumps. Viscosity, we can go all the way up to about 2 million centipoise. 2 million centipoise is the highest that I've worked with for viscosity. When we talk about the environmental market, this is about 50% cake. Solid size up to 3 inches, although it really is about how you size the cavity size for your compression between the rotor and the stator. That cavity size has to be big enough to handle whatever you want to move through that pump. So when we talk about progressive cavity pumps and the environmental market, as well as other markets as well, these pumps started to get a bad name in the market years ago. And what we're presenting on today is directly relative to that. Progressive cavity pumps, when it was time to do maintenance in the past, were kind of a headache. You had to disconnect the discharge piping, disconnect the discharge branch, twist off a tightly compressed and fairly heavy stator, disconnect the suction piping. The suction housing had to be pulled forward after being disconnected. You'd have to pull back this elastomer sleeve or boot and knock out a pin just to remove the rotor. Then you would have to rebuild this pump altogether again. This might take 2 to 3 workers and perhaps a full day's work. So although these pumps were workhorses and lasted for a long time, when it was time to do maintenance on it, or if there was something that needed to be troubleshooted with the pump, it was not very easy to work on. So the main discussion in this presentation is new technology. So the new technology that was developed by not only Seepex, but other progressive cavity pump companies was to come up with a maintenance in place design, which also allowed for pump adjustability. Seepex broke into the market with a pump called the SCT, Smart Conveying Technology. The SCT, as you can see in the video, is maintained in place with 4 metal adjustment plates. Those plates can be loosened or tightened depending on what you want the pump to perform. The stator would split in half, hence the SCT split stator, which exposed the rotor with a pair of circlip pliers, could be pulled out similar to a plug and play action. So not only was this pump able to be maintained and repaired in place without touching any piping, but this pump was also adjustable so that the end user can get longer life out of the spare parts and the wear items on the pump. This right now is simulating the pump being rebuilt with 2 pieces of rubber, which are the stator, the metal adjustment plates, which are always reused, and a new rotor, which was put in the plug and play design. So although there are other pumps out there with other progressive cavity pump manufacturers that have tried to do their own maintenance in place design, in 2009, Seepex came out with the smart conveying technology and has surpassed most of the competition and is now the #1 sold progressive cavity pump in North America as of 2019-2020 numbers. SCT product applications. Flows 4 gallons a minute to 500 gallons a minute on the max. This pump is able to overcome pressures up to 120 psi. The elastomers that are available in the split design range from Buna all the way to exotics such as urethane or Theraban. The markets that you would put this pump in, besides environmental for sludge and polymers, you would use this for food and beverage, for perhaps food waste, breweries with spent grain, and any sort of food or cosmetic slurries. For pulp and paper, these pumps are used in starch at the wastewater facilities and for pumping various chemicals. Lastly, these pumps are also used in mining now, mainly for mine runoff water applications. So when we look at the SCT, lower operating power due to the compression fit, smaller drive power requirement due to its adjustability, a lower operational cost for the customer because of the spare parts, and the ability to beat this pump up more. So the rotor and stator can be replaced in minutes. You do not need to touch any of the piping around the pump. The universal joint does not need to be changed unless there is some sort of damage to it. You've hence doubled the life of your components because the pump can be recompressed as it wears. You can get the compression back between the rotor and stator back to almost original factory tolerances. There's less spare parts. The customer does not need to buy metal for this pump ever again. They can just buy 2 pieces of rubber for their stator. Proactive maintenance. Because the pump is starting to reduce its flow per RPM, rather than speeding up the pump, the operator can recompress the rotor and stator. Recompressing the rotor and stator would happen over time. Let's say after 3 years, the pump started to reduce its flow per RPM. The operator could tighten this pump back up, get it back to its original flow conditions, let that wear again over, let's say, a year's time, tighten it again back to original tolerances, and let that pump wear for perhaps a 3rd time. When you look at how this design has increased the life of progressive cavity pumps, typically at this original loss in flow, at this set point right here, conventional progressive cavity pumps would have to either be sped up per RPM to overcome a certain flow, or the rotor and stator have been compromised and need to be replaced. Here's a video showing the retensioning of the Seepex progressive cavity pump SCT model. As you can see, we have a flow and RPM. The RPM does not change. The flow increases every time a wrench is used to tighten up one of the retention plates There's only two tools that are needed to work on this pump. One is a wrench, and two is a pair of circlip pliers. Again, we're showing that it's basically like a tire. The end user would tighten all of these bolts equally around the pump. The pump is running, and you can see the flow increase in the line. Without compression, this pump technology does not work properly. So why would an end user use this new technology brought to the market by Seepex? Well, number one, it makes their lives easier. Two, there's a 3-year factory guarantee on the wear parts of this pump, which is the longest warranty on the market. 3, the operator has the ability now to beat these pumps up. They can get more life out of their spare parts because of adjustability. 4 is higher productivity and less downtime, because now it only takes one person and maybe a few hours to work on this pump, rather than a few people, heavy lifting, and perhaps a day's work. And then lastly, this allows operators to upgrade existing pumps and aging equipment with this innovative technology. A couple examples of aging equipment that's out in the market are still these plunger style pumps. This is one example where you see a lot of ancillary equipment around this pump. You've got pulsation dampeners, you've got extra valves, you've got sludge that's now open to the atmosphere every time there's pulsing, and you can only work on one side of this pump. This pump here was replaced with an SCT, as you can see now. Ability to work on either side of that pump, and here are the retention plates on the outside of that pump as it starts to wear. A side view will give you a better idea of the before and after. Other applications for these pumps. This right here is in Block Island, Rhode Island. As you can see, there's 2 progressive cavity pumps with a common header. The drives are back here. These yellow plates are covering up the mechanical seal. Typically, we would have suction coming in this way and discharging out that way. This is your split state or wet end. And this is a thermal probe that is sensing for temperature inside of this pump, all provided by Seepex. This is West Haven, Connecticut, waste activated sludge application. What we wanted to show here is that not only can these pumps be retrofitted, but the suction housing can be rotated in 4 different directions for ease of retrofit, minimizing any sort of piping changes. This picture right here is in Disney. This is showing that we can put these pumps in outdoors in rough conditions. Sometimes at Disney, these pumps get relatively hot. And so we've installed thermal devices on all of them to make sure that these stators do not get compromised by high heat. This is an example of an old diaphragm pump being replaced with progressive cavity pump. Moving on, thickened sludge and cake applications. For moving a product such as thickened sludge or cake, the solids percentage increases drastically, sometimes up to close to 50%. You need a special type of pump to move this type of media. Seepex specializes in this sort of application by installing open hoppers and augers onto our progressive cavity pump in order to take a product this thick and pump it over long distances and sometimes very high pressures. Most of these hoppers are installed at a dewatering press. And are used to transport that thickened sludge or cake to something such as a truck to be hauled away, as in this application right here. So let's talk about open hopper pumps. Most of these pumps have a square or a rectangular feed hopper. This length is 100% custom. So when we look at this portion of the pump, just the hopper itself, that is 100% made custom for the application, because most of the time we're working with another OEM, such as a belt filter press company, where we're sticking our pump underneath their discharge. Conveying capacities for open hopper pumps, 1 gallon a minute up to about 1,300 gallons a minute, and very high pressures. We can overcome up to 540 PSI. So these pumps will be used in any sort of a thickened sludge or cake application where you're comparing it to the cost of a conveyor. A progressive cavity pump, when you're pumping over a certain distance, will always win. So when we look at these open hopper style pumps, there's a lot of different applications that they're used in. Most of them are for thickened sludge and cake, but when we look at the food and beverage industry, okay, they're used for a lot of vegetable waste. They're also used in the poultry industry for applications such as dead on arrival birds. I like to show this application, although it is not for the weak stomach. These are full birds being tossed into an open hopper progressive cavity style pump with an internal macerator. The bird is moved with the auger to the macerator, chopped up, and then pumped as part of a waste application. That's on the waste side. On the FDA and 3A approved side, we have honey mustard marinated chicken breasts that can also be pumped with a progressive cavity pump. This application was moving chicken breasts to an X-ray machine before going to packaging. So we'll touch on open hopper pumps towards the end of this presentation. I'd like to spend some time now talking about progressive cavity pumps being used as chemical metering pumps, because this is one of the fastest growing markets for progressive cavity pump manufacturers. There's a lot of advantages and characteristics of using these types of pumps. Number one would be that there's low pulsation. This can directly relate to chemical savings. There's also a very high dosing accuracy. This is important for any sort of profit-driven company, specifically food and beverage, or a municipality that is looking to cut costs on chemical usage. Conveying capacities, we can get down to literally drops per minute, all the way up to about 264 gallons per hour for a chemical metering pump. Another impressive feature is that these chemical metering pumps can go up to 360 PSI on the discharge pressure. If you look at the cutaway of a progressive cavity pump, chemical metering pump, this rotor and stator, to give you the relative size, would probably be about the size of your index finger. So the pump works exactly the same as a large one. It is 100% modular, but everything is much, much smaller. You can see back here, you still have your drive end, your mechanical seal. This is your suction housing. There's a small universal joint here with a coupling rod, and that connects to the rotor, which is relatively the size of your index finger, compressed inside of a miniature stator that is can be screwed in and screwed off of that pump. Threaded in, threaded out. So when we did a survey, progressive cavity pump manufacturers did a survey to the Northeast water treatment market. What are you looking for in a chemical metering pump? And the three answers were: they need something accurate, they need something repeatable, so every day they can come out and make sure that it's working exactly the way it should, so they don't need to do too much calibration. And three is that it has to be stable. This cannot be a pump that is unstable and has leaking conditions, and one day is working and one day is not working. So when you look at a progressive cavity pump, we can fix all three, and we can meet all three of those demands from the Northeast water treatment market. Again, the pump works exactly the same as its larger pumps that we discussed earlier for sludge and for cake. There's a compression fit extremely tight between the rotor and the stator. Because of that compression fit, this style pump has the lowest slip on the market out of all pump technology. Low slip is a direct relation to low shear, which is why if you look at most polymer systems at wastewater plants, they will have a progressive cavity pump moving that polymer. Lowest pulsations on the market, lowest shear, lowest slip. It's how you maximize your polymer usage. So when you look at most of the pumps on the market, they do have some sort of pulsing technology. This is the fastest growing market for progressive cavity pumps because of their low pulsation capabilities. Sodium hypochlorite is a good application to talk about. There's a lot of different diaphragm pumps out in the market, and they usually overpulse hypo in order to hit a certain set point and tie it in with a centrifugal pump. When you're overpulsing, you are using more chemical than you need to. By switching to a progressive cavity pump with minimal pulsation and a 4-to-20 signal, you can tie in your centrifugal pump with your hypo pump, a progressive cavity pump, and bring that line closer so they're in sync together. You are using less hypo than needed. So why are progressive cavity pumps entering this market, this water treatment or wastewater treatment, this chemical metering market? Why are they in there? Well, in the past, they made some pretty heavy duty skids for the metering for food and beverage industry. Profit-driven businesses wanted chemical metering skids that could meter accurately, that would not be dosing or pulsing, and would be able to blend certain chemicals together while making money for the actual company. Here is another example of one. Drastic difference between a sanitary food and beverage skid versus something for the water treatment market. This is an example of a polymer system with 3 progressive cavity pumps mounted on the bottom here, close to the floor. This video right here was provided at the ACE Water Show. This shows different types of chemical metering technology. They are all pumping coconut oil to show pulsation and shear rates. So this first pump here is a hydrosol. If you move down the line, the second pump here is a progressive cavity pump. And as you can see, laminar flow, very little shear. And gentle handling of that coconut oil. So we move on to other technologies. You can see that there's some tremendous shear on that coconut oil, breaking up the particles. Some of it is actually sticking to the sides of the discharge. Here we have our diaphragm pumps. These are pretty self-explanatory due to the pulsing and the ticking along of the coconut oil. And then the last pump on the line here, this is a peristaltic or a hose pump. As you can see, there is pulsing once that shoe keeps turning around here. As that shoe turns on the rubber hose, there is a pulsing action. So as we discussed before, why are these pumps great for chemical metering? Well, if there is any sort of changes in the system due to pressure or viscosity, the progressive cavity pump will still meter very accurately. It is a linear curve. This is key for any sort of metering, blending, and flow control. When we look at the majority of chemical metering pumps out in the market, most of them are diaphragm metering pumps. These pumps require pulsation dampeners. They do not eliminate the pulsation. There's no true process control. Some of these may require some back pressure or anti-siphon valves, and those are added expenses and maintenance. And then lastly, these pumps have a hard time handling sodium hypochlorite, and they'll need degassing valves. This can cause interruptions to the system and downtime. Diaphragm pump versus a progressive cavity pump. Progressive cavity metering pumps are now replacing diaphragm pumps out in the market because they require none of the previous things in order to provide low pulsation laminar flow. This will help an operator achieve accuracy and repeatability. Compression versus clearance. As we discussed earlier, a progressive cavity pump is a compression fit between a rotor and stator. When you look at gear pumps and lobe pumps, there are clearances or tolerances within that pump. This can lead to slip and internal recirculation. So if you're looking for a great polymer pump, you would not want to start at a gear or a lobe pump. Peristaltic hose pumps. These are also a very popular pump on the market right now for chemical metering. These pumps do pulsate as that shoe turns around and compresses that hose. Hose life is typically 6 to 8 months. Progressive cavity pump stators generally last 2 to 5 times longer, resulting in a seriously lower cost of ownership. Peristaltic hose pumps also require pulsation dampeners. This is an added expense for maintenance. But the largest issue when surveying the market is that most of these pumps are unpredictable on when that hose is actually going to break, wear down over time due to that shoe turning on it. At what point is that hose going to break? Operators have a hard time with predictive maintenance for these pumps, and they are sometimes messy and dangerous when dealing with certain chemicals if that hose does break. When we go back to a progressive cavity pump and its curve, chemical metering applications would be successful in calibrating these pumps because it is all about the RPM. Once you find the RPM and you go up, you can find the flow, and these pumps are easily calibrated. And then for predictable maintenance, as that flow starts to drop per RPM, a chemical metering plant would know when that pump is getting tired. So when we look at shear, applications that shear is important in: paints and pigments, polymers for the environmental market, latex, coatings, slurries, and then when you look into the cosmetics industry, you've got creams and shampoos. When we look at shear rates with various types of pump technology, the lowest shear pump on the market are the progressive cavity pumps and the hose pumps. As you work your way down the line, you can see that there's the lobe, the diaphragm pump, the screw pump, and then you get into the gear pumps and centrifugals due to their clearance fit. How are these chemical metering pumps configured? The suction and pressure branch can be made out of various types of metal, as well as the rotor. Typical applications, if you were using, let's say, a polymer, you would use a 316 stainless steel rotor, 316 stainless steel pressure and suction branch. If you were moving something like sodium hypochlorite, we would use a CPVC housing and a titanium miniature rotor. We look at the various stators that can be used on our chemical metering pumps. Anything from Buna and EPDM and Viton, which are the 3 most popular, down to exotics such as Theraban, urethane, and Chemres. On the seal side, you can use packing or mechanical seal. And on the drive end, there's a lot of different choices on how you want to drive this pump. If you want to make this pump intelligent, you can slap on a piggyback VFD that'll take a 4 to 20 signal. Seepex has standardized on this with our chemical metering pumps because this way it can be tied into a system, into SCADA, or be tied in to match and correlate directly to the speed of a centrifugal pump. Key applications for us. If anyone was interested in using or trialing a progressive cavity pump for chemical metering, there are a lot of different references of various chemicals that we keep internally and end users that would be happy to talk about the performance of their progressive cavity pump for moving things such as sodium hydroxide, sodium hypochlorite, potassium permanganate, and ferric. So as I said earlier, I wanted to talk a little bit more about open hopper pumps and where the industry is going and how progressive cavity pumps are changing the industry as far as moving extremely viscous products, especially long distances. This right here is the newest product that has been launched by Seepex called Smart Air Injection. What Seepex has done is taken a typical open hopper thickened sludge or cake pump. There's a clean out port down here. Right here is your rotor and stator in a split stator formation for adjustability. There is a laser that is installed for level control. We have a compressor for air injection, a ribbon auger, and a small polymer injection pump. So as the cake enters the pump, the ribbon auger conveys this to the rotor and stator compression. It also cleans the bottom of the hopper. This laser will tell the pump when to speed up or slow down based on the level in the hopper. When you're pumping something this thick a long distance, the pressure goes up and up and up, very high levels. So what Seepex has done is uses a small polymer pump to inject a sleeve of polymer and coat the piping. This reduces friction. There's also a pressure sensor. Once that gauge gets too high, a slug of air will be injected into the line, keeping the pressure at the pump always below 60 psi. This can allow an end user to use a smaller progressive cavity pump, a smaller footprint, and a smaller diameter piping in order to move something as thick as, let's say, a 30 to 40% cake. This is where the market is heading, and Seepex has developed this technology, just launched this year. In the past, to move something as thick as a 30 or 40% solid, long distances, you would need a gigantic pump. What Seepex has done here is utilize a single stage progressive cavity pump, a complete package system, including an air compressor and a small polymer chemical metering pump to inject a nice lining of polymer. You have the split stator option for pump readjustability, a laser level control to change the speeds, and a hopper with a self-cleaning ribbon auger. Please contact me if you'd like to learn more about this product or need some assistance on cake applications. Just to give you an idea, one last video of what that looks like on the discharge. This was pumping cake up to 400 meters. To finish up, if anyone is interested in trialing a new type of dewatering or sump transfer pump, most people don't think about it, but progressive cavity pumps can be semi-submersible. So picture this style pump mounted on maybe a sump or some sort of a pit that needs to be dewatered. You can mount this pump in 4 different ways. Fluid will be pulled up as the pump runs in reverse. Fluid will be pulled up into the pump and discharged out of this branch right here. The motor and seal would be above ground. Every other part of that pump could be submerged. These are used predominantly in the oil and gas industry, but are now being used to replace many, many centrifugals in the mining market. These are the 4 different ways that this pump can be installed, either hung from a crane, mounted on top of a sump, or mounted on the wall. That's all I have for slides for today. Thank you very much for the opportunity to present on new progressive cavity pump technology provided by Seepex and other pump manufacturers. This is my contact info. Please feel free to reach out with any questions or upcoming projects.
Hey, Chris, it's Jerry. Thanks a lot. Chris and Sherry, can you hear me?
Yes.
Okay,
Yeah.
great. You're allowed for this pump.
Jerry, can you repeat the question?
The question is, what is the maximum temperature allowed for the progressive cavity pump?
That would be depending on the elastomer choice. Most of the progressive cavity pump elastomers would limit us to about 350 degrees Fahrenheit. Although if we went to a metal to metal option with low discharge pressure, you could probably go to higher temperatures than that.
Okay. Thank you. Number 2, are progressive cavity pumps cost competitive with diaphragm pumps for chemical dosing?
No, I would say that diaphragm pumps would be on the lower end of initial cost of ownership, but higher end on the OPEX costs of ownership. So the initial purchase price of a diaphragm pump would be lower than, let's say, a peristaltic and a progressive cavity pump. But when you look into the cost of ownership, including parts and labor, a progressive cavity pump may show some savings. When you look at initial costs, a progressive cavity pump would be head to head with a peristaltic or a hose pump on the market.
Yeah, and my only other comment to that, I think that's fairly accurate, Chris. My only other comment is it does depend on what type of diaphragm metering pump. If it's a small little solenoid
LMI.
pump, right, little LMI or solenoid pump, certainly that's going to be less expensive. Once you get into larger flows, if you have a mechanically actuated pump, then the cost difference would come down a little bit. In the event that it's a real high flow and there's any reason you would need a hydraulically actuated diaphragm pump, now both the progressive cavity and the hose or peristaltic would probably be less. 2 more questions. Can these pumps be used for strong acids like sulfuric?
Yes, we have applications where we put these pumps on sulfuric acid. Again, it is about finding the correct choice of elastomers in combination with a rotor metallurgy that'll work.
And so if they had an application, they just need to get the details to us or to you, and then you would take over from picking a material standpoint, Chris.
Correct. There's a lot of different things that we would ask as far as initial questions, but mainly if we knew exactly the type of media that we needed to move percentage-wise, it would just be about finding the right elastomer and metal choice. As long as there's elastomer available and a metal, and we can compress it to make a rotor and stator, we're in good shape.
What is the maximum suction distance Seepex can handle?
27 feet, and that is all depending on NPSH-A. What is NPSH-A? Net positive suction head available in the system.
So when you say 27 feet, do you mean a 27-foot draw from a pit?
Correct. So if you were in a perfect condition with the perfect pipe diameter, the longest suction lift that Seepex has done is 27 feet.
Got it. Okay, those are all the questions. I want to reiterate that you have to complete the survey evaluation that will appear, and then I think we're good. Thanks very much, everybody, for your participation. Have a great day, and obviously, please stay safe.
We'll stay on for one more minute so people can download their certificates. And then when we end the seminar, the survey evaluation will pop up.
Thank you, Sherry.
Okay, I'm going to close down now so you guys can all do your survey. If by chance you didn't get your certificate of completion or something happened, it will be in the follow-up email that you get tomorrow. So thank you, everyone, and have a wonderful day.